Hello everyone, welcome to my channel. Today I am going to talk about LangGraph. So why do we need LangGraph? Basically, when we are trying to create or work with the LLMs, it is not as straightforward to just ask a question. When we go into solving bigger problems, we have to break down the task into multiple tasks, subtasks. So and then operate on each of these tasks. So the LLM needs to answer or find a solution for the first subtask, and then on the answer from the first subtask, we need to decide whether to perform subtask 2 or subtask 4, something like that. So there are a lot of complexities, but we can handle it easily with writing long Python codes. But also there is a framework which help us arrange this task in a way, put a decision task in between. It makes the code look neater, I would say. So that is the primary objective of LangGraph. So let's dig deeper into it and check out the functions and features of these framework. But before that, the usual request: if you like the content of my channel, please like the video and subscribe to my channel. So the first thing that we will see is linear graph, where we will have an input and there is a function which will do task 1, and there is another function following that which will do another task, and we will finally have the output. Let's go into the code. And as always, the code is available on GitHub, and the link to the GitHub repository is available in the description of my video. Okay, so over here we will see that how to create a linear LangGraph. I have 4 functions defined. Over here in function 1, I am accepting an input, and then I am adding high to that. In function 2, I again accept an input, adding there. Thereafter, in function 4, agent says, things like that. Pretty simple functions, doing not much more complicated things. To understand the concept, we will keep it simple. Once we understand the concept, we can make it as complicated as needed. So this is the primary code section where all the magic is happening, where the framework is created. So this is the library that we need to import. Very simple. We can install it using pip install LangGraph, and then we create a workflow object, and then we are adding nodes to it. So if I go back to the slide, each of these we can call as function 1 and function 2 as nodes, and the line in between as an edge. So over here we are in the workflow, we are adding our first node, which is node 1, which is function 1. We are naming it as node 1. So in function 1 we will be adding high to the input. Then in node in next we are adding node, so that is node 2, that is function 2. So then again we are adding there to the input. So these are 2 discrete nodes that we have created. Then we are using edge. So to connect these 2 nodes, we need an edge, that is node 1 and node 2. Then we are defining that set the entry point as node 1. So this is the starting point of the workflow. So first node 1 will be executed. If we had longer chains, then it will be we will need to execute a lot of these nodes, and then we need to stop somewhere, and for that we will need set finish point, that is node 2 in this case. Then we just call this app to compile the workflow. So let's quickly run it and see. Done, and then we are printing. So over here you see I am passing hello as an input. I execute that. So hello hi from function 1, then hello hi there from function 2. That is all that we are doing, right? So input that we provided comes into function 1, hi gets added, so hello hi, and then that hello hi both are being passed into function 2, which adds there at the end. So hello hi there is what the final output we are getting. So this is a simple linear graph, quite easy to understand, I hope. If you have any queries, you can put it out in the comment section. I will try to answer them. Moving on to the next one, which is decision graph. Often we need to decide on the response from function 1 and then decide on which function to go, function 2 or function 3 or 4, like that. So over here we can see that we have a few more imports to be done. This is the base message. Now in this case we are introducing one more thing, that is agent state. Agent state, we are basically creating a message, and annotated with sequence base message operator is add. So what does operator add do is basically what we saw in the above example, that it will be adding to the already whatever is already there in the message. So message will be a dictionary, or state will be a dictionary within which message is a keyword, and this message will have the output from each of the functions added to it, right? So over here I have modified the functions a bit. So in this case we are passing on state. So why are we doing it? To make it simple again. So lot of functions, lot of messages will be there, input and output. So to have them all in a single variable kind of thing, a compound variable we can say, so which is state in this case, which will have one keyword as message, and then thereafter we can have multiple a list of values which we have to identify and utilize in each of these functions. So that's that. And over here you see I am getting the state and state message, then this is messages, but I am having another one variable message hi, so I am adding that basically to message. So over here you see messages, I am passing message. So over here whatever is the add operator will do is whatever is there already in messages, it will add message that is hi to it. Similar happens in 2. Over here in 3 what I have done is I'm saying if message 0, that is what I have initially passed is hello, then return node 2 or return node 4. So this is my decision function where I will decide that what has been initially passed. Based on that I will go either to node 2, which will be this one, as I will go next when I define the workflow, or I will go to node 4 where I will be adding agent. So let's see, adding the node function 1, 2 and 4. So 1, 2 and 4 are 3 simple nodes that we have seen already in the above example, but function 3 is not a simple node, it is a decision node. So we have a different function for that, add a conditional age. So we are not adding it as a node as such. So what we have done is from node 1 we are supposed to go to function 3, and I have now decision needs to be made. So if the return is node 2, we will go to node 2. If the return is node 4, we will go to node 4. So this is how it is written within so it is a dictionary. So based on the return, there can be multiple returns. Based on the return, you can imagine it to be a switch case kind of thing. Then we are adding age. Now it's a little bit tricky over here because from node 1 we don't have any direct node to node 2 or node 4. So there is a conditional age. So this node is basically from node 1 to function 3, and from there we are going to node 2 or node 4, right? So that will be handled internally, but node 2 or node 4 needs to end somewhere. So that is where this end is being provided, which is coming from this import. So this end will terminate the workflow, and we are setting the entry point as node 1. That's how we are compiling it. Now as I said, the decision will be made what we pass in the input initially. So if it is hello, we will go to node 2 where their message will be added. If it is something else, we will see that it goes to node 4 and agent will be added. So over here when I pass message 0 and then invoke the workflow with inputs, right? So over here you can see joy, hi, and agent has been added to the list. Similarly, if I pass hello, this time message gets hello, hi, and there, which is coming from node 2. This is from node 4. So that's all there is in a LangGraph on a basic level. And with this now you can see how we can create LLM agents where we can pass the response of 1, parse it, get the required information, decide on that, and then change our prompt and call the LLM again to do the next subtask. This way an agent is basically created. So this is the basic framework for creating LLM agents. Hope this was helpful and I am able to clarify and simplify the concept of LangGraph to all of you. Thanks for being here. See you in the next video. Bye bye.